Let's solve this problem, whatever we have, and solve it here by filling all these numbers in this bottom up approach. We are going to do the same implementation in Java. So I have opened here my IntelliJ in the presentation mode. So let's start coding this same algorithm here. And I will just create a dummy method here. Let me check back in the longest common subsequence. Okay, and just copy this method and paste it here. I like to make it final to make it immutable. And I will call this method longest common subsequence, and text one is ABCDE and text two is ACE. Yeah. So here it should give me the solution that we discussed here. So we can see that now here is a 2D array of length of row and column A, B, C, D, 1, 2, 3, 4, 5, 6. I mean, if the length of this text one is 5, it would be 5 plus 1, 6. Similarly, for text 2, where its number of columns is the length of ACE text 2 and additional 1. So first of all, we need to have, we have one more thing here, that constraints, we don't need to do any null checks because it is guaranteed to have at least the length of 1. So I will not check any whether that text 1, text 2 is null or not. We'll just start with the implementation. Okay, so a final int row. Okay, it should be text 1 dot length. Final int column. Now we just use call. And the 2D array that we defined here, it's row plus 1 and column plus 1. It's a 2D array. So in Java, by default, the arrays are initialized as 0. Here it would be row plus 1 and col plus 1. So we need to start filling this array from starting from the bottom. So bottom row E and the last column. So it would be 2 for loop. So for example, I will just start with for I int I should be row minus 1. Row. It is a text total length. That is 1, 2, 3, 4, 5. So it should be 5. And text length is 5. So it should be starting from row minus 1, right? And as far as it is greater than equal to 0, because we have to start from here and move up to till here. It should be I minus minus. This is for the row. And now for the column, the same thing. We start with j is equal to col minus 1, and j should be greater than equal to 0. Same what we did for the rows. Okay, now we start from this position, and the formula we already know that how we are going to check this. So if say text 1 dot char at I, we're talking about this character, text 1 dot char at this I, because we are starting from the last row minus 1 is this, is equal to text 2 char at j. It means the characters are matching. And we know from this formula that characters are matching, it should be 1 plus the diagonal of this, the right diagonal bottom. So it should be the dp we are going to fill at this array is this 1 plus this. dp at I j is equal to 1 plus dp I plus 1, that is the next right diagonal, bottom diagonal. Okay, I plus 1, j plus 1. I plus 1 is this, I plus 1 is this, and j plus 1 is this. So here you go. And if else, means if it doesn't match, then it should be I j. It should be math.max. Max of this or this. So in Java, we already have math.max doing the same thing. Should be dp I j plus 1 dp of I plus 1 j. I j plus 1 means same I j plus 1 column is this max of this. I plus 1 j is I plus 1 is the row, and the j is still same, so it's this one max of this and this. So this is all the formula about. And finally, once we complete this, we need to return whatever the value is at 0 and 0. Right? This is the final solution. Just return dp 0 0. So let's go through it again. We found the final row and column, the length of text1 and text2, because here we have got rows as text1, and these are the columns for the text2, ACE. And then we initialized our DP array with all 0, the row plus 1, and because we have this extra terminal null characters for overflow or the base case. And then we iterate from here back to the up using the same formula that we have found here. So if characters are matching, we find 1 plus the right bottom diagonal to it. If it doesn't matches, then it should be the max of the cell next to it and bottom of it. So let's run this and see whether it gives me the correct answer, 3. Okay, we got the correct solution here. Now let's, because we can't do all different type of test cases here, so I will paste the same solution in Leetcode and see whether it's the correct solution. That's the main reason why I'm using Leetcode, so that we cover all the cases which are automated here. So we have put everything here, the same code, pasted it here, and let's submit it. Okay, we see that our solution works, accepted, and faster than this. Okay, so this is how we have solved one of the most common or most popular dynamic programming problem, longest common sequence, using the bottom-up approach. We first broke down the problem into recursive approach by using the recursive algorithm. We found the recursive algorithm, and then we try to find out that whether the sub-problems are overlapping. Whenever we find this type of condition, we know that we have to apply dynamic programming to change the time and space complexity into linear level if possible. And then we've used this bottom-up approach to fill this grid, and exactly same thing we implemented in Java here. So let's check out what is the space and time complexity. As we see that we are using 2 for loops, and it iterates to the length of this text1 and text2. So the time complexity, first of all, it would be row multiplied by column, right? Because this is how we are iterating it here. Or in other words, the length of this text1 multiplied by length of text2. And the space complexity would be similarly O of, because we are using 2D array here, it would be row plus 1 or column plus 1, or it would be same. So space and time complexities are still same. So it's like a square. Or you can say only like we can define it as n square. Okay, so in the next video, we'll tackle the next problem, which is the longest increasing subsequence. So let's solve that in our next video. Thanks.